Hello, everybody. Welcome on behalf of the Center for Crisis Studies and Mitigation at the University of Manchester. My name is David Schultz, and I'm professor of synoptic meteorology and PI of the center. The purpose of our center is to bring together different researchers across the university who work on natural hazards and their impacts on society. So this is another one of our continuing seminars in our series for the past few months. I want to thank Dr. Pon Suvanasang, formerly of our center, for selecting the speakers, organizing, and advertising. To stay informed of our activities, please remember to follow us on Twitter at Crisis Studies, or check out our website for event updates and video postings. The format of today's talk will be as follows. During the seminar, you can enter your questions in the chat box. If you're watching on the live stream, you can email your questions directly to me or enter them in the chat box there. We'll do our best to get to them all during the question and answer session. For now, let me introduce our speaker, Professor Kathleen Sherman-Morris. She's a professor in the Department of Geosciences at Mississippi State University. Her research focuses on communication of weather information, risk perception, human responses to weather hazards, and issues of diversity in geoscience education. She has a PhD in geography from Florida State University in 2006. She served as a secretary for the Southeastern Division of the Association of American Geographers, a counselor or board member for the National Weather Association, state coordinator for the Community Collaborative Rain, Hail, and Snow Network, and she served as the chair for the American Meteorological Society's Board on Societal Impacts. The title of her talk today is called Tornado Warning, Communication, and Response, Results from the Southeastern United States, with an emphasis on individuals who are blind. Professor, take it away.
All right, thank you for having me, and thank you for accommodating my time zone. All right, let me see if I can share my screen now. Pick the right one. All right, that work out okay?
Looks great.
Okay, good. All right, yeah, so you just heard the title of my talk. I thought I didn't know who the audience was going to be, so I wanted to start out with a little bit more background information. So first of all, I wanted to just talk about where tornado risk exists. And you can see on the map, North America is one of the main locations for tornado risk. And my talk is going to focus on North America and specifically on the Southeast. But you can see that there is tornado risk in other places in the world. There have been tornadoes on every continent except Antarctica, as far as I can tell. And so you can see that the UK has tornado risk, and in fact, one of the largest European outbreaks was in the UK in 1981, though there were no fatalities, according to Dr. Greg Forbes. All right, so my talk is going to focus on the US Southeast, and I wanted to start with this image here on the right. And on my screen, my picture is blocking it a little bit. Hopefully that isn't the case for everyone. But the image on the top shows where tornadoes are most common, all tornadoes. But the image on the bottom shows where killer tornadoes are common. So when there are tornadoes, where are they most likely to be fatal? And you can see that the bullseye exists right over Mississippi, Alabama, Tennessee, so the southeastern United States. And there are several reasons for this. Tornadoes in the southeast tend to be nocturnal. So this is a map showing the percentage of tornadoes that occur historically at night. So you can see the southeast has a high percentage of tornadoes that occur at night. Visibility is also an issue. So there are physical factors And social vulnerability is an issue, a big issue, in fact, for the Southeast. So these things contribute to making tornadoes in the Southeast more fatal when they occur. So I have a couple pictures to illustrate some of these factors. So the picture here on the left is an example of an EF4 tornado in Louisville, Mississippi. And I wanted to credit Alex Puckett, as one of our former students who's now working in Huntsville, for taking this picture while he was storm chasing. So you can see in this picture, there's trees, there's hills. The tornado itself is rain wrapped, so it's hard to see. There's dark clouds that are close to the ground. And you can compare this to a tornado in the Great Plains in the United States. So the one on the right was taken by someone from NOAA, Brad Goddard, and this one's in Iowa. So you can definitely see the difference. The ground is flat. You can clearly see that there's a tornado in contact with the ground. It doesn't look like just a thunderstorm. And then vulnerability, social vulnerability is another factor. Things like poverty, presence of disabilities, minority presence, English as a second language. So these are, and housing. These are some of the factors that contribute to the Southeast having high social vulnerability. So the blue counties are ones that the CDC considers higher social vulnerability. And Mississippi, where I am from, or where I live, I guess, I'm actually from Pennsylvania. A lot of our counties are in this 75.75 and higher social vulnerability. So we have mobile homes. We do have a large minority population. Poverty is a ever-present issue in Mississippi, as well as parts of the Southeast. So these factors contribute to our social vulnerability, to all hazards that affect the Southeast, but especially to tornadoes. And a study by Simmons and Sutter in 2011 looked at some of the key tornado vulnerabilities just across the United States. And the factors that they considered that led to the greatest vulnerability, or that would lead to tornado fatalities, were percentage of nighttime events, events that occurred in the fall or winter months. So if you look at, let's see, this figure over here in the upper right, you can see that there are higher than average tornado fatalities in the winter months at the beginning of the year, as well as at the end of the year. So mobile homes also contribute to tornado fatalities. And there are actually more fatalities that occur in permanent homes just because more people live in permanent homes. But you can see that overnight on this map here, chart here on the lower right, there are a lot more fatalities per tornado in mobile homes at night than permanent homes. And then permanent homes have a little bit more during the day, and then in the evening, mobile homes have more fatalities as well. Fatalities per tornado. And the Southeast, they found that the Southeast was itself a factor in tornado vulnerabilities. Moving to some research that I did about, let's see, I guess a little bit longer now. When 2013, I published a paper where I looked at 25 years worth of tornado studies, and it looked at other hazards as well, but this is just a chart showing tornado statistics that I found from the different papers that I reviewed. And I looked at where people received their warning, were people aware of the warning, and then did they seek shelter? So of all of the papers that I studied, and you can see the number here of studies that it's reflected, about half received warnings from either siren or television. About 3/4 were aware of or received the warning, and almost the same amount sought shelter. Now, I do think there's a little bit of bias in these numbers because these studies tend to be done after major events. They are typically ones where tornadoes did occur, as opposed to sometimes there's a warning that there isn't a tornado, or a weak tornado that maybe someone doesn't need to take shelter in. So they may be slightly biased that way. But you do see that most people were aware and most people did take shelter. Awareness and confirmation, these are some of the issues that I am interested in my research. And so I just put some pictures here to show some of the most common ways that people become alerted to tornadoes. Wireless emergency alerts on your cell phone, your smartphone. Those are becoming the most common way that people receive warnings, especially at night. Some recent research by Ellis et al. Found that overnight people are more likely to receive their warnings from their smartphones, the wireless alerts, than they are from other sources. But even in 2020, television is still a very common way that people both receive warnings and help confirm the warnings. And this guy here, if you're not familiar with him, he's one of our most famous meteorologists on TV that talk about tornadoes, or he's well known for his coverage of tornadoes. His name is James Spann, and he allowed us to use some of his footage for a paper that a grad student and I published in 2016, where we looked at some of the things he was saying and whether he was on screen or off screen, what type of image he was showing. This particular type of image shows reflectivity. There are other types of images that sometimes meteorologists show that I don't think people understand quite as well. People sometimes have trouble understanding this type of image as well, but there are other images that people understand less than this common image, which you would also see just on a normal rainy day, though not with so much red. And then, of course, sirens. People do hear warnings from sirens. Sirens don't offer much. They don't allow people to confirm anything. There are some sirens now that will actually speak to you and provide some additional information. So those are probably more effective. But in past research that I did in, after a tornado, people often complain about the sirens going off unnecessarily. And we also saw this in the study that I'm going to be talking about in a couple minutes. Sirens don't really allow you to confirm the warning. They just alert you to it, kind of like the smartphone warnings. And then you have to go to another source, such as the television meteorologist, to confirm the warning. And confirmation is very common, and it's a very important process, or part of the process, to convincing someone to take shelter. And then seeking shelter, most of the people in the papers that I reviewed did seek shelter. I just threw some pictures up here to kind of illustrate. Most people take shelter just in their homes, but sometimes people's homes are not safe for them to take shelter in. For example, if people live in a poorly anchored mobile home, or an older mobile home, or even a site-built home that's not structurally as sound as, say, some stronger brick or masonry framed homes. There are public options in some communities. So this is an example. This picture up here, taken by, I forget if his name was Tom, but taken by someone that works for FEMA. This is an example of a community tornado shelter. And I actually have a grad student right now who part of his dissertation is looking at community tornado shelter use during COVID. So he has some interesting results that he will hopefully be publishing soon. And then this is a kind of shelter that you can just have buried in your yard. Sometimes people have things, safe rooms installed inside their houses to make them safer. So people do tend to take shelter. One thing that I wanted to mention, that as part of that confirmation process, sometimes time passes between when people hear the warning and when they take shelter. They spend a lot of time Some people call it milling, where they're looking for information. Sometimes people go outside to see if they can see the tornado. So that is something where if you do live in the Great Plains, maybe you can see the tornado coming from very far away and you don't have anything that would, stand in its path. But if you're in the Southeast, you might have trees and hills and those kinds of things. So that's where visibility can really play a role in helping to keep people safe, or preventing people from staying safe, I guess. Okay, so hopefully that's enough background. So I'm going to talk about one project at length, but before I do that, I just wanted to briefly mention a project that just began this past year, and we're a little bit delayed due to COVID, but this is a project that I'm excited about, and we're just kind of getting it started. So I'm working with Jason Sankvale at the University of Alabama, and I was hoping to be able to have some results to talk about today, but we're not quite there yet. But we're looking at how people personalize their threat geospatially. So what kinds of places do they identify with? How far away do they need a tornado to be, or to perceive that tornado to be, in order for them to take protective actions? So these are the research questions that we're going to be looking at. Does their personalized risk differ based on their personal characteristics? What if their personalized risk area is different from an objective map-based risk area? Does either have a dominant influence on risk perception? And it can be important because people do a lot of their own, fact-finding during the confirmation phase. They look at things like the radar on their smartphone, or they look at where they're located in a tornado polygon. So how are they imagining this risk? How are they perceiving this risk spatially? And does that risk feel to them like it's significant enough for them to take shelter? So some of the things we'll be doing, and this is the last slide I have on this particular project, but we are about to start our survey. It's in pilot testing now, and it will have some graphics. It will also get at some of those research questions about the geospatial risk perception. This is the part that was delayed. We were supposed to start with interviews, and we were going to actually have people, and we still will, but it will either be delayed until COVID is done, or we're going to have to think about some new methods that we can employ that will keep people safe. But we're going to have people draw sketch maps and illustrate their county. What do they know about it? What kind of places do they think about when they're listening to tornado warnings or watching tornado warnings? And then we'll also show them an actual, a real map, and have them do sort of similar things. And we'll analyze the results geospatially using a GIS to look for patterns and that sort of thing. So really excited to begin this study, and hopefully we'll be able to get it kicked off in just a week or two, and I'll have results to present soon. Okay, so that said, this is the main project that I'm going to talk about for the rest of the time. Okay, so this is a project that has been going on for the last 2 years, and it's a project that I'm also working on with Jason Sankvale and Darren Griffin, and it's improving accessibility and comprehension of tornado warnings in the Southeast for the deafblind and deafblind. And both of these projects were funded by NOAA's Vortex Southeast program, which is, it looks at how can we better both predict the actual, the physical threat for tornadoes, and then how can we better keep people safe? How can we encourage people to take protective action, understand warnings? How can we reduce the number of people that are killed by tornadoes in the Southeast? And for this project, I'm also working with the National Research and Training Center on Blindness and Low Vision, which is centered at Mississippi State. So they were instrumental in helping us get to this population. So my portion of the research at Mississippi State focused on people who are legally blind and living in Alabama or Mississippi. We did have one person from Louisiana, and the University of Alabama, they focused on the deaf and deafblind. So we did some things very similarly, and then they did some things where they actually tested American Sign Language interpreters and translators to work with TV meteorologists. So I won't be talking about that part, but if people do have questions, I can try to answer questions about their part of the research as well. So we had 2 rounds of phone interviews, 25 in the first round and 27 in round 2. And both of them were semi-structured. And so we had a list of questions, and we allowed people to elaborate, especially in the first round, where we were really just trying to understand things, explore things with the participants. In round 2, we also included some quantitative measures. So that's more, well, I'm going to be talking about the qualitative stuff from round 1, but mostly just the quantitative part from round 2. So for round 1, some of our research questions were, how do people who are blind currently obtain tornado warning information? What are their preferences regarding the warning process? How does it inform them if they're at risk and they need to take action? And what barriers currently exist regarding tornado warning communication and response? And I did want to mention, since I didn't mention it on the last slide, that our population was people who were legally blind. So that's a specific definition that allows for some usable vision. So we did have some people that could see some, and some people who had no usable vision with difference. Some people could perceive light perception or could perceive that there was light. Some people didn't even have that. So we had a range of people who were legally blind. So first we asked about their sources that they used, and we found that this was very similar to the cited population. Phone alerts and television down here were the most frequently mentioned sources used. And then when we asked them for their preferred source, we also saw that that television and phone alerts were the most preferred. But you also see some things that maybe are a little bit more specific to this population. The NFB Newsline would be an example of one of these that multiple people mentioned. NFB is the National Federation for the Blind, and this is just sort of like a news source for them, but if there would be a warning, it would pop up to alert them. But they would have to be on this web page or on this app, or it wouldn't alert them like a smartphone, makes a sound to alert them. So things that are audio tend to be more important for this population, I guess for obvious reasons. We asked how they know it was a real threat. And a lot of people took that to mean, what source again. So they gave us similar information. But a lot of people talked about specific message information that they received. Just like I mentioned with the past studies, environmental cues are important for people who could see somewhat. They still mention things like clouds or the way the sky appeared. There were also some things like a person's guide dog showing signs that there was something going on, or things that they were listening for, like rain hitting the windows in a certain way, or one person mentioned patio furniture being moved. So things that were sound cues that they also listened for. And you can see from the relative position on the graph here that environmental cues were not mentioned to a large extent. I think they are some of the more memorable things that people said during our interviews. And then the TV meteorologist was one of the common things. People also said that, well, they would be aware of the threat that was coming. And it seemed like for this population, several people knew that because they might be at higher risk, that they felt more responsibility to be aware ahead of time. So that was another interesting thing. So looking specifically at message information, this is where some of the key themes from this project started to come out. So geographic information was mentioned over and over again in the interviews. Trajectory, I consider things that are both a place as well as like a vector, like it's moving at a certain speed or a certain direction. So again, it also includes an aspect of geographic description. Some of the other things included like how severe was it? Is there circulation? Was there a warning? But these were less commonly mentioned items. And then safety information, like the meteorologist saying you need to take shelter now, or things like that. But geographic information, a very common thing. So we asked them what they liked and they disliked about warning information as it currently is. And we separated the text that we transcribed the interviews and separated that text into things that had to do with the source and the message, and analyzed them. So these are some comments about the source. So some of the things that they either liked or didn't like, the message being too fast, the usefulness of the audio. There were issues mentioned with the crawl or the closed captioning. The crawl is the thing that goes across the bottom of the TV screen. And the closed captioning tends to be bigger and bolder than some of the little things that you can see on a map. So it would be useful for someone with some usable vision. But going back to too fast and the closed captioning, people mentioned that it was difficult because it went through fast, and then if they missed something, they have to wait for 2 or 3 minutes for it to go back and cycle through again. So this was also an issue they mentioned with NOAA weather radio. Convenience was an issue. Well, convenience was something that made people more likely to like a source. And then smartphones were one of the things that were cited as being convenient. It's always on you. It makes an alert tone. So it's good in that way. And then general oral quality had to do with things like it not being clear, text not being spoken or put into words, just not being loud enough. Personalization would have to do with like the specific ability to like what specific information did it give. Like a siren would not really be a personalized source for a warning, but television or radar might be more personalized because you could actually like zoom into your location or listen for your location on the map or in the warning coverage. Some comments about the message really kind of echoed some of the things that they mentioned earlier as far as how much they know that it's a threat. And so again, we saw geographic description, description in general. Some of the things that the people we interviewed, they mentioned if they didn't like their current warning process, some of the things they mentioned were, well, the TV meteorologist says things like, you can see right here, and the storm is moving this way, and over there we have this. And if you can picture yourself not actually following along visually, some of that information is almost useless, because unless they're actually saying, look here at the intersection of Highway 50 and 182, you can see that there's, or we see that there's some circulation that might, be a tornado. Things like that, where just inserting some additional words make the warning information more accessible for this population. And so again, trajectory, geographic description, Precision also kind of gets at that personalized geographic information. I put a star next to understandable and radar because we asked people specifically about them. So I included them in the chart, but it doesn't necessarily mean that more people talked about radar voluntarily. We just asked people to talk about it specifically. But we did ask them if radar was useful, and it was useful for most people in the study. For people who had no usable vision, they even recognized that, well, I might not look at the radar myself, but it is useful because that's how meteorologists tell if there's a threat. We also asked them, are there any barriers for you in accessing information about tornado warning? And the first step for analyzing these responses was to group them in sort of the phase of the impact for them. So is it a barrier that prevents you from being aware of the warning? Is it a barrier that prevents you from assessing your own risk to confirm or say it's not a threat for you? Or a barrier could be in the response phase. So you see that most of them do happen in that communication phase, but it could be partly because that's the way the question was worded. Looking at some specific barriers, cannot see the information. That would be an example of something where it was probably either a confirmation barrier, like a barrier to prevent them from confirming the warning or assessing their own risk. People mentioned specific things that I characterized as knowledge barriers, such as their geography, like not knowing where other places were in relation to them. This can be a factor for somebody that just moves to a place, but it can also be a factor for people who don't have a lot of experience, with maps and with their looking at places around them. Then we did actually have 6 unique people say that they had no safe place to go. I know one of these people lived alone in a mobile home. So that would be a very clear illustration of some of the vulnerabilities that exist and how they can be magnified by having a disability and living in a place that's not safe. Makes that person even more vulnerable to the tornado hazard. Some of the information that they were interested in, that they felt like they couldn't see, environmental cues, the radar, visuals. One person had a quote that was really interesting, and he more or less felt like being blind prevented him from having the same sort of like agency in looking at the tornado warning information as people who had full use of their sight, where if he heard a warning, he wasn't able to access the same information that his coworkers could. If they heard a warning, they would get out their phone and look at the radar. But because the radar was something he felt wasn't accessible to him, he didn't feel like he was capable of making his own judgment over whether it was safe. So he had to rely on other people. And you could tell from his discussion that bothered him, that he really wished that there was a way that he could better use the radar information. So some conclusions from the first part. Number one, detail, but especially geographic detail was the most important. And one person likened it to speaking like a radio sportscaster. If you listen to a game on the radio, people have to be a lot more detailed with what they're saying than if you are just somebody showing highlights on the nightly news. It tends to be a lot more vague, and they also do these things like, oh, look at that kick, or where you're not actually describing the kick. It's hard to imagine what it looks like, especially for people that cannot see. So we took some of this information from round 1 and we used it for our round 2. So I'll finish just talking about this part of the project. So based on round one, does an increased level of geographic information improve the warning message effectiveness? So we played participants what I'll call a fixed warning. It was just a warning for the city of Birmingham, Alabama. And we changed it to have more or less detail. And then we also prepared for them a personalized warning using their city to create a warning for them with more or less detail. So I'll show you an example of that. For the warning for Birmingham, we actually had somebody who was a professional read it so we could play it and it would sound like somebody who was a professional. And then we also used an experimental text-based probabilistic warning. And this is the type of tornado warning that NOAA is moving toward, being able to express tornado probabilities and then move those probabilities through time. So, on this chart, here's the tornado probability now, and then this will evolve every so often. So they hadn't, when we started this project, figured out how to translate this into text yet. So we worked with them to translate it into text so we would have something for this population. And then we asked, how helpful is this warning? How bad do you think it is? And what would you do? So this is an example for the current warning format. And I included an example of a whole warning for people that might not be familiar with what tornado warnings look like. So they're told that there's, and this is an example of a personalized one, that there's a severe thunderstorm capable of producing a tornado. They're told the impact. This is something that was added to warnings a few years ago. And then locations impacted may include, and then they were actually read both of these in varied order, where the lower detail might say rural central Dallas County, Selmont, and Selma. And the higher detail might say rural central Dallas County, Old Cahaba Archaeological Park, Selmont, Selma, Craig Airfield, and Wallace Community College. So not just the cities, but also some places that people could relate to. So that's what I'm talking about when I say the difference between higher and lower detail. So some of the results, so we have helpfulness results, followed by the severity results. And then the fixed one was just for Birmingham. Everybody got that one. And then the personalized one, it was different for everybody. So you can see that the one with more detail did lead to slightly higher ratings on a scale from 1 to 10. So these are the means and the standard deviations. These were not statistically significant. The helpfulness of the personalized warning, this was significant at p is less than 0.1, which the p was 0.09. So not typically considered a significant result, but our population was only 27 people. So it may be a meaningful difference, despite having not a traditionally low enough significance. And then the severity, I will say the fixed warning, the difference in the severity between it and the personalized is attributed to the warning being more, it sounded more dangerous. So we weren't actually comparing those two, but we were comparing less detail and more detail between those. And you can actually see that some of the more detail, the severity of the personalized warning actually went down, perhaps because people were listening for their own location. It's just a thought. We don't know for sure yet. We'll probably be able to dig into some of their comments a little bit more later. And then we asked them what they would do. And so these are the results for if we coded them as taking shelter. So the warning with more detail for Birmingham did lead to a higher percentage saying they would take shelter. The personalized one, a higher percentage, but this wasn't significant. So it's kind of a theme for the results that there were differences, but they weren't significant differences. And then this probabilistic text warning. So what we did is we took the example from the National Severe Storms Lab, and I made this sort of template where there was an area I defined as 70% and an area I defined as a 50% probability. And so then I looked at this template over their particular location. And so this is an example of what a probabilistic text warning might look like. And this was reviewed by people at the NSSL, and they provided feedback, and we tweaked it a little bit. So this could be how a text-based probabilistic warning would look, but I don't think they really fully know yet. So there's a 70% chance of a tornado affecting the following locations, and at least a 50% chance affecting these additional locations. So the people that we interviewed, these were set up so that they would be in this 50% additional location. And then one thing I'll point out, tornado may form outside these areas. Probabilities will be adjusted as the storm evolves. So people picked up on some of these things that are not commonly in a normal or a current warning format. So if we look at the last chart with the probabilistic ones added in, you can see that the helpfulness is very similar to especially the warnings with less detail, and the severity is perceived as lower. Now people are in the 50% range, but the actual warning polygon of a current warning does cover this same area. So it's not like we added area in these warnings. This would be included in a current warning. So they perceived less severity, and they were much less likely to say they would take shelter. Less than 30% said that they would in the probabilistic warning than in the personalized warnings, which were closer to 60%. So much less likely to take shelter upon hearing the warning, but what would they do? They would pay attention. They would look for more information. They would call friends. And so it had the lowest rate of taking shelter. But they did use this 50%, as sort of a get ready, heads up. The warning may not be high for you right now, but maybe it will evolve into the future. So some of the favorable things they had to say, there were lots of details, information, specific landmarks. These were not really different things about the probabilistic warning, but they were things that they liked, just like in the first part of the study. Some people liked percentages and probabilities. More people liked these than did not like them. I guess they felt like they were getting more information, more useful information. And some people mentioned that they liked that the warning actually said that future updates would be coming, and they get prepared. One of the things that people said they didn't like about the current warning process was the lack of we sometimes call it the all clear, where you come out of your safe place, or it's safe to go about your business again. So people like to have that continuous, refreshing of the warning information. And then one person said that the probabilistic warning was more real, like the television broadcaster, and that it mentioned danger outside of the area, which the current warnings, it's considered either in the polygon or out, without any sort of mention of being outside the range. Some things that were not favorable were the probabilities being hard to understand. And one person talked about the probabilistic warning as being sketchy, with too many ifs. And this is something that sometimes we hear about probabilistic weather information, that like if somebody says it's a 60% chance of rain rather than it will rain or it won't, well, they're just hedging their bets, or things like that. But this was only 1 out of 27 responses that actually said that. So conclusions from this part, higher level of detail seemed to be an advantage. though not always statistically. People did talk about the level of detail. Details were mentioned as what made it more helpful. People listen for specific locations. So that can be a good thing or a bad thing. One person said that with the lower detail, they had to pay more attention to where they thought the warning was, rather than the one with specific locations. They could key in on a few specific places. So if people are only listening for more, for places that they recognize, rather than trying to understand how the warning plays out spatially, that could be a bad thing for putting too much detail in. But I'm not going to say that detail is a bad thing, because most of our results said that people really want the detail and that it was helpful. The extra locations were confusing to some people. There's a certain level of information that someone can process cognitively. So if they're having to process too much information, it can be difficult for somebody, especially people who can't also confirm where these locations are visually. And then, of course, the probabilistic warning did not lead to shelter taking as much as the current warning style. But people were listening. They would use it to wait for more information, and broadcasters to get people to get ready, to pay attention. So one thing that I will point out while I'm on this slide, the images on the right show, the top one is a common type of radar, and then for people that are normal, that have no color blindness issues. And then the two on the lower right side are for people with different types of color blindness. And there's actually a website that you can use to see if how an image, or how like a radar image or a map or something would look to people with different types of color blindness. So it's cool to do that, and to make sure your graphics are accessible. So I just wanted to end with acknowledging the sponsor, NOAA, through the Vortex Southeast program. And then I also appreciate our participants, the National Research Center on Training, National Research and Training Center on Blindness and Low Vision for recruiting the participants, and then my graduate students, Cole Vaughn and Taylor Pekacek, for help conducting the interviews. So with that, I'll take any questions.
Great, thank you. Do we have any questions? People want to put them in the chat box. I'll start off with one. How large are the deaf and blind populations in your part of the world?
Mississippi has a higher percentage of people who are legally blind. I think in the United States, there's about 3 point something million. As far as deafness, I'm not positive, but some of these issues, that would be the population who would be considered legally blind. But these are also issues as people age, where people become hard of hearing, some vision impairment. So if you expand that to people who are not just legally blind or legally deaf, it can encompass a whole lot more of the population.
Mm-hmm. Mm-hmm. So we have a question from Grady Dixon. How do you convert these findings into actions for professional meteorologists?
Yeah, good question. So the detail is the one thing that has resonated the most with the broadcast meteorologist. I used the same quote to talk like a radio sportscaster at last year's NWA, and it got like tweeted and retweeted like so many times. People really like that analogy. So the level of detail, and this seems to be something that when people are starting out as broadcast meteorologists, they're not quite as familiar with their area. Like James Spann, the guy that I showed earlier, He is just a proponent of getting to know your local community, your local area, hanging out at all these local places. So he knows everything about his market. But when you just start out, it's hard to get that level of familiarity. So trying to build that level of familiarity can help you better communicate the information. As far as NOAA, there is, a little bit of information that they can take as far as the types of places in the warning. I think the second study that started will be a little bit more useful, because we're actually trying to get at what kinds of places people think about when they're personalizing their warnings. And then the information from the probabilistic warning. I mean, we were the first to take their picture and put it into text. So I don't know if they were able to use that to test the warning test bed yet, but it at least, I guess, maybe helped them to get thinking about, not just how am I going to translate this project that they call facets into, television where you can see the picture, but how are we going to translate this into NOAA weather radio or a crawl or things like that. So there's bits and pieces from different parts of the project that will be useful to both NOAA and private sector broadcast meteorologists.
I think that raises an interesting question that, I mean, I guess being earth scientists or meteorologists, we're very familiar with maps. We're used to looking at maps. We love maps, probably even as children, we were fascinated with geography. And for most people, I imagine that's not the case. And you kind of alluded to that and suggested, this is where this next project is going. But I mean, do you have any sense of, what fraction of people are just spatially aware of, where, if you were to take a map of their state or the United States and just say, where are you? How good are people at identifying where they're at?
Some of the geographic literature suggests that people are pretty poor, especially in the United States, I think, at locating states, other countries, things like that. There have been projects that have looked at like hurricane evacuation maps, and people have had trouble locating themselves in their proper risk zone for that map. So I do expect that we will find some issues, and some of the local meteorologists, the National Weather Service meteorologists, have talked about this, that people have problems with locating themselves. And actually, one thing that we've seen on Twitter too, where a lot of times the interaction between the meteorologist on Twitter and the followers are, does that affect me? When they talk about a warning, well, what about my community? What about my neighborhood? What about my street? So they're seeking that extra guidance and in helping, that person helping them locate themselves. So I think it's a big issue. So hopefully we'll have some good solid results from the survey and the interviews that we're about to do.
And you mentioned that obviously you weren't involved with the studies with the deaf at Alabama, but could you speak broadly about the comparison between your results and any results that you're aware of from their work?
Mm-hmm. Some of the results were very similar as far as the ways they're getting warning information, some of the things they would do upon hearing the warning, or not hearing the warning, receiving the warning. One of the main differences was the way that they like to receive the warning, with the use of the sign language interpreter being better than the closed captioning or the crawl. So the crawl was an issue for both samples, the blind and the deaf, but where people who are blind might prefer to have better accessibility with either converting that into things that can be read, and or at least slowing it down, making it more obvious for people that had some usable vision. People who were deaf really wanted the use of an interpreter alongside of the actual warning. So the folks at Alabama, they created this mock-up where they had a person on TV doing the warning communication, and then they had someone translating that warning to American Sign Language, and then they had someone else using that translation to actually deliver the information to the public. So it was a 3-step process because some of the information, it sort of benefits from having that translation. Like if you can imagine like going from English to Spanish, there are some words that when they're translated literally, they might not make sense. Well, the same thing happens when you translate from, English to American Sign Language. They had that translator to help it make sense to the people. So they actually brought some people in who could do that, and they found that it was very, very challenging, very taxing for the interpreters and the translators to take a warning and actually communicate it. Some of the warnings were a little bit simpler. So we have different kinds of events, and some of the events where, there's just a few sort of, EF1 tornadoes, those events were easier to interpret than they also had like an outbreak where there were, several supercell tornadoes. And they found that a person could really only sign for about 15 minutes at a time before they needed a break. Like it was very taxing for them.
And I imagine that they have to spell out the locations too. I mean, there's just not a simple sign for Birmingham or, Choctaw or whatever. They have to, spell out each character. And, if you've got one of those expanded lists of, that goes on for 2 or 3 lines of locations, that could be really tiring. And you'd end up really far behind where, the actual person who's speaking is saying, what they're saying.
Yeah. That's a great point. So it was very challenging. They hope to be able to actually try this in a live event where, maybe it won't be like on the TV channel that you're watching, but like that they can have somebody and, put it online somewhere to test it out in real time. So, it's exciting to think about, though.
Yeah. Any other questions in the Zoom chat room before we close up? Okay. So again, thank you for coming. And if you're interested in our center's seminars, then please check out our website, and we'll see you in the future. Thanks again. Thank you, Kathleen. That was wonderful.